We are Team Atmanirbhar, and today I'll walk you through a technical approach for solving the problem statement in Smart India Hackathon 2025. Our project, Floatchat, is an AI powered conversational interface designed for Argo Ocean data discovery and visualization. The challenge is that ArgoNet PDF files are complex and traditional methods for querying and visualizing this oceanographic data are slow, error prone, and not user friendly. Our solution makes ocean data accessible through natural language queries, interactive visualizations, and automated insights. So let's deep dive into our approach. Our approach is a three-phase method. So I will like to start with phase 1.
So the first phase establishes a solid foundation, the data banking. We first start by acquiring sample Argo NetCDF files which focus on the Indian Ocean. These store the large-scale oceanographic data which are difficult to interpret directly as they are having a specialized structure. So our goal is to convert this unstructured data into a structured format. For this, we designed a Postgres SQL schema which is used to store the key profile information like latitude, longitude, temperature, pressure, timestamp, and other parameters. To automate this, we created a Python script using XArray, SQL Alchemy, and Psycop G2. This script parses the netcdf files and stores the extracted data into the SQL tables. But that's not all. To support the intelligent queries later, we generate the content summaries for each of the data profile using a local large language model, especially the GPT OSS 20B. We then embed these summaries into vector representations using sentence transformers and store it in an FAISS vector database for efficient similarity search. Now the outcome is a structured database coupled with a vector database ready for retrieval augmented generation queries. This makes our backend capable of handling both structured data and also natural content efficiently.
Now, moving on to the second phase of our project. The second phase deals with the core intelligence of our project, the agentic backend. We will build a fast API backend that exposes a simple slash query endpoint that can handle all user interactions. When a user enters a natural language query, our pipeline will follow these following steps. First, it will embed the user's question into a vector using embedding models such as sentence transformers and search the FASS vector database that can retrieve the most relevant summaries for it. These summaries, along with the database schema and the user query, are passed as an MCP object in a clean and organized structure using PyDent. We have designed a custom and unique LLM architecture that can combine the prowess of both GPT OSS with 20 billion parameters and QL with 14 billion parameters to perform text to SQL generation along with few short prompting. This allows the system to translate natural language into SQL queries that can run on our structured PostgreSQL database. To improve the interaction quality of our chatbot, we have integrated memory integration in it. The chatbot keeps track of all the previous queries made by the user, and this will allow the user to have continuous and consistent conversations with it. To tackle the general technical challenges faced in a normal text to SQL query generation, such as query errors and ambiguous questions, we will implement our unique actor critic architecture. The actor proposes a SQL query while the critic checks its correctness. If it feels the query is good, then it will pass it to the PostgreSQL. But if it thinks it is bad, then it iterates back to the actor until an accurate result is achieved. The final outcome of this phase is a robust agent that can reliably convert natural language input into actionable SQL queries, providing accurate data results.
Now, moving forward, in the third phase, we have focused on the front end and user experience. We have developed a streamlined web application featuring a chatbot interface linked with the backend. The user can type in natural language and the system responds intelligently, making the data exploration simpler. For visualizing the results, we have integrated Plotly maps to display geospatial visualizations such as flow trajectories, depth time profiles, and parameter comparisons over time. Users can see intuitive graphs showing how temperature, salinity, or pressure changes along the trajectory and compare parameters across flows. Results are displayed in interactive tables, which user can export in various formats such as ASCII, NetCDF, or structured tables. Finally, the system will generate a natural language summary of the result, making it easier for the user to understand complex data insights at a glance.
What makes Floatchat stand out? Our GAN-inspired LLM core architecture iteratively refines SQL generation through actor-critic loop. We offer automated data synchronization, that is, any updates in Argo files are detected and reflected in real time. Our LLM memory integration enables continuous conversations so that users can build upon their previous questions. And all the models and components which are used in this project are offline and open source, which ensures privacy, adaptability, and cost efficiency.
Our solution advances innovation by unlocking hidden patterns in the ocean data, facilitating fast and actionable discovery. It supports environmental monitoring, aiding conservation, and climate resilience. Moreover, it bridges the gap between academic oceanography and real world data, enabling students and researchers to easily explore complex datasets. Thank you for watching. We look forward to contributing to the future of ocean data exploration with the Float Chat.